Basic concepts of physics. Physics. Physics is the study dealing with the nature and properties of matter and energy and their interaction with each other. Matter. Matter is any substance that has mass and occupies space. For example, we have solids, liquids, gas, plasma, etc. Energy. Energy is defined as the ability to do work, and it has many forms. Example, heat, electricity, kinetic energy, etc. As per the law of conservation of energy, energy can neither be created nor destroyed, but it can be transferred from one form to another. That is, the total energy of the universe is a constant. To study this matter and energy, we need to measure these physical quantities. For this, we have what we call as the units. Unit is a quantity adopted as a standard of measurement. Fundamental and derived units. These are the two kinds of units. Units which are independent of each other and has their own standard base are called as fundamental units. Example, kilogram, meter, seconds, etc. The units obtained from the fundamental units and not having their own base are called as derived units. For example, we have velocity, for which the unit is meter second raised to minus 1, and area, meter raised to 2. Prefixes used to describe small and large units. The units which we use can be large or small. The prefixes used to describe the large units are tera, giga, mega, and kilo. And the prefixes used to describe small units are deci, centi, milli, micro, nano, and pico. Common units used in radiography. kVp, that is kilo voltage peak. Kilovoltage. Kilovoltage is the potential difference applied between anode and cathode of the X-ray tube. P, which represents the peak value of the kilovoltage. Peak value is used since the PD is varying in nature. MAS, milliampere second. Milliampere, that is ampere into 10 raised to minus 3, as we have seen on the top. This is the number of electrons flowing each second from the cathode to anode. This constitutes the tube current, and it is related to the amount of X-rays produced, which in turn produces the film blackening. S is the time of exposure. keV, kilo electron voltage. This is the unit of energy used in radiology. It is a smaller unit than joule. This is equivalent to kinetic energy gained by a falling electron through a potential difference of 1 volt. 1 electron volt is equal to 1.6 into 10 raised to minus 19 joules, which is also equal to 1.6 into 10 raised to minus 12 erg, which in turn is equal to 4.4 into 10 raised to minus 26 kilowatt hour. Heat units or HU. Heat units is the heat produced for a single exposure in the X-ray tube. HU is kVp into MA into S. Temperature scales. Temperature is usually measured using 3 scales: centigrade scale, absolute scale, and Fahrenheit scale. In the centigrade scale, melting point is 0 degrees Celsius, boiling point is 100 degrees Celsius, with an interval of 100 units between these 2 points. In the absolute scale, melting point is 273, boiling point is 373, with an interval of 100 units between these 2 points. In the Fahrenheit scale, melting point is 32 degree Fahrenheit, boiling point is 212 degree Fahrenheit, with an interval of 180 units between them. For converting one unit into another, the formula is given. Next, we will be looking at the graphs. Graph usually has 2 axes, x-axis and y-axis. X-axis or abscissa. X-axis contains independent variables such as time, distance, etc. The y-axis contains dependent variables such as velocity, exposure, etc. By looking at the graphs, we can see linear graph and a semi-log graph. Graph on the left hand side is a linear graph. As you can see, on the y-axis, measurement increases in a linear fashion, and in the x-axis also it increases in a linear fashion. That is, the interval between each measurement is kept same. On the graph on the right hand side, you can see the y-axis, the interval between each measurement, it does not increase in a linear way. It increases in an exponential way. As you can see, 0.1 and 1. It is 10 times more than the previous value. And the next one is 10, which is also 10 times more than the previous value. And on the x-axis, it is in a linear fashion. So this is called a semi-log graph or a log linear graph. In a linear graph, y varies with x in a proportional way, and a linear plot can be drawn on this graph. It obeys the equation y is equal to mx plus c, where m is the slope and c is the intersection of the line with y-axis. In a semi-log graph, y varies with x in an exponential fashion, and in this a logarithmic plot can be drawn.